going to step away now from the physical robot and focus on robot simulation. This is an extremely important set of skills, especially at a K-12 level and also in industry. Most high schools only have maybe one or two robots, but also a class of 20 plus students. So using Fanuc's RoboGuide simulation software, you can actually have the entire class interacting with that physical robot. When you flip over to industry actually does 70 to 80% of their programming offline using RoboGuide, running simulations, running diagnostics and data analytics on work cells before they actually put them into the production facility and actually implementing them with physical robots. So the things that we're going to cover today in robot simulation is how to open RoboGuide. There's a few different ways of doing this. We're going to do a crash course intro to Handling Pro, which is the subset program of RoboGuide that we're going to be using. And then we're also going to focus a bit on RoboGuide features. I'll tell you now, we're going to be scratching the surface of all the capabilities of RoboGuide, but it's some really cool, powerful software that really helps us get across some great learning. So what I'm going to focus on right now is opening RoboGuide. There's a few different ways to do this. I'm going to go over to the Start menu. When RoboGuide is installed, it automatically creates a Fanuc folder, a Fanuc Robotics folder. And in here, you're going to see a few different things. You're going to see something like icons for Handling Pro, License Manager. You see RoboGuide, 3D Player, Robot Neighborhood. The main thing that you're going to want to focus on is either using the RoboGuide icon or Handling Pro. They take you to the same exact thing. Remember, RoboGuide is the overarching program platform. Handling Pro is what we use for material handling. There's also other types of subsets of RoboGuide like Weld Pro or Palette Pro for palletizing or Paint Pro for powder coating and painting operations. So here we're working with Handling Pro because we're doing material handling on our robot. So I'm going to shift over here. I just created a few shortcuts. The first one, this is the first way that you could access RoboGuide. You can double click on the Handling Pro shortcut, and what it's going to do, it's going to pull up essentially like an introductory wizard. There's a couple of different things you could do. We could go back to a recent work cell that we've previously worked on. So here I've opened up a fenceless cert cart digital twin. I've also opened up a work cell example. Those are embedded and built in with the program. I can also create a brand new cell. And what this does is it starts this work cell creation wizard, where it takes you through step by step of adding a robot, choosing exactly which model and type that you want, what is the function, what's the operation, which controller that we're going to be using. I don't necessarily recommend doing this the first time around, but just know you can create a totally custom work cell with different end-of-arm tooling. You can actually import STL files, things that you've designed using SolidWorks or Autodesk, and build out a work cell that either mimics your lab or creates a totally new operation. So just take note that that's an option. If we go and look at Open Work Cell, this is where we can see the sample cells that are available. Again, we're working with Handling Pro. And you're going to see a couple of different ones. I like to always pull up this work cell example at the very bottom. And what this opens up is an example of a palletizing robot moving a part from one pallet to the next. You'll see what we're actually opening up is a virtual robot controller. So this is essentially a digital twin of the same exact programming software, controller, teach pendant that we have on our physical robot. So when this fires up and opens, you're going to see a pretty large robot, not similar to the one, it's going to be quite a bit different than the one that we use on our fenceless cert cart. but it does teach all of the same stuff. The cool thing to note is that, when you look at the controller and the teach pendant and the robot that it's operating, if you're familiar with the fenceless cert cart, you can operate those huge robots that lift up cars or do big palletizing operations. So this is just pulling up another example of the sample work cell. Here you see our sample robot work cell. Here again, just simple 2 pallets with 2 parts. This is a good example that you can pull in and incorporate. You could start out with. More often than not, I recommend working with our digital twin of the fenceless cert cart. So the robot that we're actually going to be running all of these labs. So what I want to point out here is we have a zip file that you may or may not see either on your desktop or in your student server. I like to call this is a source file. So every time I open this up, I want to extract and drag and create a new copy of that source file, because we can actually push this out to any computer. Students can have a copy of it, and if you make changes within the zip file, those are permanent. So I always like to keep this separate as a source file. So when this is making a copy, I can do something like create a Mike's fenceless cert cart and then the date, or pulling up, we can go in, we can change, and you can have multiple cert carts, student cert carts on a computer that are saved, so you can have students working through the lab and not mess with anyone else's work. So the third way to open up RoboGuide, so we've talked about using the icons and going through a wizard to create a new work cell. We can open up a sample work cell, or probably the best way to do this is to go into a copy of that fenceless cert cart, that digital twin, and scroll down to find this .frw, or it has a little robot icon. Double click that, and it is going to open up our digital fenceless cert cart. All right, once the robot work cell is open, you're going to see a digital twin of the robot cert cart that we have over in our lab. You're going to see the table here, the cart, the controller, the teach pendant, and that LRmate 200 ID4S. What I want to focus on right now is just kind of a crash course intro to working with Handling Pro. There's a few different traits that are going to be a little bit different than working with our physical robot. The first thing I want to point out is there's several icons up here. And of course, if you hover over any of these icons, you'll see that it'll pull up a little description of it. The most useful one to start out is there's a show, hide, mouse commands. So I definitely recommend working with a Bluetooth or wired mouse, because that's going to make it the easiest way to navigate RoboGuide and manipulate the robot. So there's some really useful features on here, just like using a wheel. You can zoom in and zoom out, so a wheel on the robot. If you right click, you will actually rotate. And right click also kind of depends on what are you going to be rotating. Like here I'm rotating the physical cart. If I left click on the robot itself, it's going to do something very similar, but if I maybe focus on a block, here I'm rotating just that block. Or something like the teach pendant, or sorry, the controller. That is also being rotating. So that's the right click. If you have a wheel on your mouse and you push in that wheel, you can actually pan, so left, right, or up and down. If you don't have that wheel, you can hold down the control button and then use right click, and that'll also help you pan. So you'll see up here that there's a couple different ways to do all of these. I primarily use rotate, zoom, and then also pan in order to work with the robot. And of course we can hide those. The other thing I want to point out is that is going to be a cell browser on the left side here, and then there's also an icon right below File that is Show Hide Teach Pendant. And this is really where it's clear. This is a digital twin of our physical robot. We can teach almost all of the same features on the physical robot of this, or same competencies on the physical robot as we can in RoboGuide by using this digital teach pendant. The main difference is that you will not need to use a dead man switch to move the robot. That's because we have a 2D digital teach pendant that we see here. I also like to point out one of the things that I like to do when I'm working with RoboGuide. There's a feature here that allows the window to be outside of the main window. That allows you to kind of have a little bit more flexibility in where you put the teach pendant. You can also make it smaller, so we can adjust the size of the keyboard. We can also adjust the size of the whole teach pendant itself if you're a little bit scrunched for space. Having a second screen also helps as well. The first thing that you're going to have to do, and you only need to really do this once, is when you open RoboGuide, if you click on the rubrics cube in the lower left corner, there's going to be an initial setup. These are preloaded. They populate all of the correct information that you need. It's pretty easy just to kind of click through the guidance. You do it once, you put in the time, you save it, and then you don't need to worry about it again. So just kind of cruising through this. I won't need to go to a network. And time and date. There we go, no network. We'll leave the touch panel editor on for now, but I'll explain the difference shortly. We're going to finish that. It's also going to set up your end of arm tool. Again, if you just follow through that it's a single gripper, everything kind of populates on its own. So direct entry, payload. You do this once, and then you don't need to do it again. All right. So here's the digital teach pendant. The main difference between the teach pendant in this cell browser is that the teach pendant is really just mimicking what we have on the physical robot. So similar to what I was doing before, I can actually, hold down shift and I can rotate the robot. I can also move it into joint mode. I can teach all of the same competencies that we would in the CERT program. One thing that might be helpful to show a real clean motion on the robot is if we go up to Tools and Options. This is something that I like to do. The teach time refresh rate, I like to bump this up to about 20. And what that does is it gives us a really nice, clean robot motion. I also want to point out here is that we can actually also hook up a physical robot teach pendant to the computer and actually manipulate the digital robot using an actual teach pendant. So that's an option that's available as well. You'll see the difference of now when I move the robot, it's nice and clean motion. When working with the cell browser, we're not going to spend too much time in this area, but this is where you see a lot of simulation programs, but you see a lot of the same menus that you would in the actual teach pendant. For example, if I can click on programs, I can see all the different programs that are available, and you'll also notice that working in the cell browser also manipulates the teach pendant over here. So here's a box counter, a simple program that's in place. We can also look at the physical robot traits in the cell browser. I can focus on end of arm tooling. So here we have a specific, our gripper that we have in place. We can also, of course, add import more STL files, add more end of arm tooling. We can adjust user frames manually, which is a nice feature. We can also look at some DCS features, as well as focusing on fixtures, parts, and obstacles. For example, the main obstacle that we have with our robot is the robot cart itself. You can see that's attached and it's highlighted. And then This is really where a lot of engineers do a lot of their programming in the cell browser. But I like to always start out, we can teach all the same stuff using this digital teach pendant right here. So another crash course in, or concept that's in with RoboGuide is there's a really important characteristic in terms of fixtures and parts. So to focus on that, similar to SolidWorks or any type of CAD program, in order for a part to exist in this work cell, you need to have it on a fixture. So with this digital twin, we've made it super easy, and there's actually two fixtures that are simply the sticker layout on our table of the cert cart. So there's a left sticker layout that highlights these parts or these blocks here, and there's also a left sticker layout and then a right sticker layout. So what it does is it makes it really easy to, if we're running a simulation program or manipulating and moving parts, it makes it really easy because it's essentially two fixtures that are sandwiched on top of each other. Most of your work in doing simulation programs or manipulating blocks is going to be done through the fixtures. The only thing that we can really do is I can isolate a specific block, like short block 2. The only thing I can really do is change the size or change something like the color. But I can't click or move it or do anything in the part itself. That's all done through the fixture. So again, similar to SolidWorks, if you want to have a part that exists in RoboGuide, it needs to be attached to a fixture. And if I click on that left fixture, here you will see at the top there's general size, scale, but then if you go over to parts, I can find that short block 2, and this is where I can actually edit where the part's going to go. So I'm actually going to click short block 2 to make sure I have the right one. Short block 2, edit the part offset. Now this is another key trait of RoboGuide. We can do direct entry of specific measurements or locations of XYZ axis. But really what pops up is when we're editing anything that's within RoboGuide, whether it's a point, whether it's a part or fixture, we do have these triads that pop up in XYZ. So real easy to do. I can drag this part out to in our x-axis. I can bring it down in Z to make sure it's level right at the base here. I can move it in Y, so I'm moving it out right in front of my my robot. I can also rotate it as well. So we can rotate the y-axis, move it on its side, that type of thing. So these triads are going to come up over and over again. Once you like where that part is, you can hit apply and then OK. So that's all I'm going to spend on fixtures and parts, but you can manipulate those parts. It flows through the fixture layout here. One more item is that we can actually take everything that we program in RoboGuide, and it's a seamless data transfer into the physical robot. So I can actually take this box counter, I can actually run the program, I can see it running through, doing a simple box program, and I can actually take this program and save it onto a USB drive, take it over to the teach pendant, and then if I need to touch up any points, I can on the physical robot, but it's going to take this exact same program parameters and it's going to be a seamless application into the physical teach pendant. There's no need for translation. It's a pretty straightforward one-to-one direct data transfer. With that being said, the last thing I need to point out in our intro to Handling Pro is that it actually uses old-time animation. And what I mean by that is you got to think about this software is being applied to any type of manufacturing setting that you could think of. So in order to do that, they actually kind of dumb down the animation so that we could have any type of end of arm tool here working with any type of part that we're using in a material handling operation. So when we do simulation programs further down the road, we actually have to define where this part fits onto this end of arm tool, whether it appears, disappears. It's really kind of like stop animation, pulling things away. So you'll see a button function right up under robot that says open close hand. You're not going to actually see the robot gripper open and close. This is a imported STL file. For example, this end of arm tool gripper. Here you see the triads again. I can manipulate it. It's an image that was designed for this robot. I can define exactly where it's going to be on the faceplate. But even if you put in a robot output, open and close gripper, even though you don't see it here in RoboGuide, it will translate directly to the physical robot. So that's just a key characteristic of Handling Pro, and that it uses old-time animation. But the reason it does that is because it's being used for any type of manufacturing operation you can think of. Now I want to take some time to show you RoboGuide features. So we've already looked at the digital teach pendant, which is really where you're going to be doing most of your programming and most of your work in using RoboGuide. But there's also some really cool visualizations, some additional features that really make this powerful software kind of come to life. So a couple of things I want to point out is looking at our menu and toolbars here. You can, of course, manipulate these and move them around by using the 4 dots here, so you can organize them a little bit. Just kind of going down the line, I like to show, this is talking about the robot's work envelope. So we mentioned dual check safety is in place. Dual check safety prevents the robot from crashing into other parts of the cart. Dual check safety often gets used in industry to prevent the robot from running into other pieces of equipment, or to limit its motion to avoid any collisions. So this is a good example of the robot work envelope. We can also scroll over. Here you're seeing some other things like cycle starts. Like if we were on the robot controller, we can hit pause or abort. That's kind of like our emergency stop. Fault reset. These are all things that are on the teach pendant, but they're also built into the RoboGuide tool panels as well. Another nice feature visualization to show is this DCS of the robot itself. So here you can see they actually have DCS in place around each joint. So if you're doing a really tight move, going from one end of the table to the next, these DCS parameters are in place, so you're not going to run into your own joints or have the robot hit itself. So some great visualizations that are available to show work envelope, DCS. We can also do some cool things like we can add workers to the work cell. We can draw features on parts. We can actually incorporate, like I said before, different STL files. So we can build out work cells in our fenceless circ cart. Probably one of the most challenging things that in first working with RoboGuide is just having perspective and that visualization of where you actually are in terms of the end of arm tool. So again, I'm using right click to rotate around around the robots and around the cart, but you can also go back up to our toolbar here and do things like, here's a top view. So we can actually have the perspective and see the exact top view of our box counter. We can look at a side view. And again, if it puts you in a different or weird position, remember, use that pushing down on the wheel or control right click to pan up. But here, this helps you give perspective of if I'm trying to move this part uh, to be in line with my robot. This gives me another good perspective that I can see exactly where all of the parts and fixtures are located. So again, here's a couple of different other views that you can see right at the cross. Here's the front. So just be aware of those. I also want to point out another really neat feature that makes the use of RoboGuide pretty simple and kind of speeds up the process of programming. If I scroll up to my top menu bar here and hit View, and then scroll down to Program Node Map, here I can see, again, more visualizations to help us run really efficient programming, but also it's a great teaching tool to see exactly how the robot moves. So here you'll see we have selected segment speeds and position connector lines. As I'm putting in programs, you can see down at the bottom here that I've got the box is actually drawn out, even though we don't have any powder coating or laser function here. It draws out the program lines, the connector lines, and it also shows the speed that it's at. It's at 100%. This is something that we're not going to be able to do on the physical robot, so we'll probably want to bring these speeds down in our program. The other thing I like to click is triads for robot positions. And what this does is it applies a little triad where if I go to, so for example, point 4, and if I click on point 4, I've got a triad here. I can actually touch up and manipulate that point using that triad. So if I actually want this point to be up higher or over here more, if I want to make a totally different shape, this makes touching up points really, really simple and really easy. So that's a cool feature that any point that we program, we can manipulate it using these triads. I'll go back up to View and look into the program node map. We can, tooling for our different CAD programs. We can actually do some show what the tooling looks like at specific positions. We can also hit up some more items like position data. So here you can see exactly the position data of each individual axis. Tends to be a lot going on there. We can show things like motion options, let's see, and even line numbers. So line 10, that would be as in line 10 in our program. So if I click on line 10, I'm going to see exactly where that item is. This is line 9. You can refer back to your teach pennant. Another cool visualization that we can show, especially when you're teaching things like user frames, is I can actually go over to my cell browser. There's an item here on the robot that says user frames. We have a default user frame built in place. If I double click on that, double left click, we can change the color of that user frame. We can adjust the position directly with specific data points, but we can also just click here, edit the user frame. User frame is our work envelope. It's where the robot is doing all of its work. I can manually manipulate this user frame using the triad. User frames essentially make it so that you can apply a program that was developed here. I can apply it elsewhere within the robot work envelope. So if I want to apply the same program up over into a completely different area, we can do that. So some other great visualizations. The manual adjustments of points. I showed that here with the triads. The other thing I'd like to point out is, RoboGuide, again, we touch on just the surface level information of all the different capabilities of RoboGuide. But there are some good help tutorials in just pulling up how to set up a work cell, doing a real simple introduction with different features. We can also go into help and let's see, can go to the content menu, and you can see a ton more information about, what is the process of actually using CAD files within RoboGuide. So how to import them in from SolidWorks. It actually gives you step by step on how to do that. So that's extremely useful. How to run a program, whether it's in full auto or in teach mode. There you'll see other things like Palette Pro, Paint Pro, pick and place, motion. You'll have a lot of information on this, but you won't be able to use it really unless you have a site or a registered license for each of those additional RoboGuide features. The one item I do want to pull out is that we can actually, even if you don't have a vision system set up on your physical robot, you can actually teach vision and have it set up within RoboGuide. So that's a feature that's available on just the standard version of Handling Pro, and it's available whether you have the hardware or software on your physical robot. So another great way to expand your program once you start moving through the core competencies of the CERT program, we can start going into adding things like a vision system. The cool part about when we do simulation programs, we can actually do some data analytics and look at the cycle time of our program, see how we can improve it. That feature can be run through the test run menu, and I can pull up the run panel. And here you will see if I click on this run or cycle start and I run through my program, it's going to time my simulation. There's a lot of different features that we can put in place in terms of what we display, how we control the tool paths, and really what is the whole purpose of utilizing automation in robotics and industry is all about that cycle time. How can we make this program more efficient within our manufacturing process? So again, simulation programs are a really cool feature of RoboGuide and definitely something to work up to. But please rest assured that if you create a robot pick and place program where you call out robot outputs, even though you don't see it run here directly, it will translate over to the robot, open and close and manipulate the gripper. In order to do something like this is run through a simulation program, which your instructor will be able to share with you and focus on that at a later point. That's all I have on RoboGuide today, and looking forward to taking what we've learned here and apply it to the physical robot. The last thing I want to share with you before we move on to our next lab is, again, we can actually take the programs that we develop here in RoboGuide using the Teach Pendant or using the cell browser, and we can save those on a USB and take them to our physical robot. So what I'm going to do, just a quick rundown of how to do this. What I want to do is first go to Menu, and then go up to File, and I'm going to click on just the first piece, File here, and I want to make sure that my directory is set to something like user disk 1 or UD1. So when we set device, there's a couple different options. We could set the device from the disk, from the physical or the virtual robot controller, so we could save it on our computer. We can save it to, if you have a mini a mini SD card. Here I like to do USB disk or UD1. I want to set that directory path. That's really what that means is we are saving a program onto a USB port on a virtual robot controller. You'll notice that there's also an option to save it on a Teach Pendant. There is a USB on the physical Teach Pendant, USB port. I always recommend to save those programs onto the controller on the physical robot, as well as here in RoboGuide. It just seems to be more reliable from my experience. So I'm going to set the directory as UD1 USB disk, and then if I go to select and I find my program, I highlight my program that I want to save. What we could do is go over to this little caret here on the end of the teach pendant, select that. We can click Save As. We make sure that the device directory is UD1. It's going to save the file name onto this USB, and it's going to save it as a .tp file. That's a teach pendant file. Make sure to save your programs as a teach pendant file. That's what's going to translate best to taking it over to the physical robot. This was our crash course in RoboGuide and working with Handling Pro. Again, there's a ton of possibilities where you can expand the use of RoboGuide, but for the purpose of the CERT program, the big advantage here is having a digital twin of our robot and a digital twin of our teach pendant, and we can teach all the same skills here that you would on the physical robot, and we can take programs from the robot to RoboGuide or vice versa. I can do programming in RoboGuide, take them to the robot, touch up points, and have an entire class working with robot software.